Okay, this is the finish up to the investigation into when fractions terminate and when do they recur. So I've got two examples. I'll quickly go through the division reminder. So if I was to divide 1 by 12, 12 doesn't go into 1, so we carry into the next column, which is 0. 12 doesn't go into 10, so it's 0. So we've now got 100. 12 into 100 goes 8 times. Yep, 8 times with 4 left over. So 4 comes down. 12 goes into 40 3 times with 4 left over. We are now repeating the same calculation. So this recur happens on the digit or the digits that this keeps coming back for. So that recurs. Now the clue to this you were given was the factors. So let's look at the prime factors of 12. And there's a lot of information we can get for it. I'll use a factor tree. Any multiplication sum that gives me 12. 3 is prime. Separate out the 4, 2 and 2. Now these primes actually tell me two things. Number one, the 3 being there tells me that it cannot be a terminating fraction. It also tells me that there is one digit recurring. So the 3 says two things. The prime factor 3 says it recurs and recurs for one digit. Okay, well, actually no, let's scrub that last one, that's not necessary. But what it does, the 2's say that there are 2 digits. Because there are 2's by 2 of them, then there is 2 digits before it starts recurring. Now we'll explain in a minute why that happens when we come into the next one. So 20 into 1. 20 into 1 doesn't go, so carry over. 20 into 10 doesn't work, carry over, so we got 100. 20 into 100 is 5, nothing carried over, it's terminated, it stops. So once I've done the last number and there's no more carries, it's terminated. So let's look at the 20 for this one. 20, let's go 4 and 5 again. And 4 goes to 2. Now, what you have to think about is what number system are we using calculating these calculations? Because we only carry things which are what are called modulo 10. We carry over the things which are in the base of 10. And it's because of that, that in that carry, if the factors of that number are 10 in the denominator, all make up the factors of 10, it will terminate. There is a point at which this division will not work anymore. So let's take a fairly obscure one. Let's try 1 over 21. Yeah, that recurs after quite a lot, it's a hard one. So that's the basic reason anyway, recurring and terminate. If you look at the prime factors of the denominator, when simplified, it must have been simplified. If you have any factors which are not of 10, two and 5, if the prime factors are not of 10, then you can't actually, the number will not terminate, it will recur. And those two, the maximum of these, so if I've got two 2's and 1 5. The number of 2's is greater, so we look at the max, and that 2 says this number will recur it will terminate after 2 places. Okay, similar reasoning for why this one, this gives me 2 places up here. If I had a 2 and a 5, 2, 5, and 30th should be good, a fairly nice one to show. So let's look at actually 150th might be nice actually. Prime factors first. 15, 10, 2 and 5, 3 and 5. Now this one says it's going to recur. The 2 5s is greater than the number of 2s, so there will be 2 fixed places. So now let's do the division. 150 goes into 1. Let's get a few places going. 150 goes into none. 0.0. 150 no. So we're down to here. We're now to 1,000. Okay. So it doesn't go into a 10. Doesn't go into 100. Goes into 1,000. How many times does that go into 1,000? Well, 6 of them gives you 900. We carry a 100 again. 6 carry 100 again. 6 carries 100. There's my 2 fixed places beforehand, and the 6 is my recurring digit. Okay. Just pull in the calculator and show you. So 1 fraction 150. There's the fraction. Press the fraction button to turn it into a decimal. Oh, and mine's in a funny mode, so let's make sure my mode is regular. No. On. Mode. I know, I've got the wrong. There we go, 3. I think it's mode 1 I want, so let's try 1 divided by 150 again. It's gone into logarithmic mode, exponential mode for some reason. Let's change my mode to 3. I tried 1, let's try 2. There, 0.066666 as I've got over here. Okay, so that's the end of that one.